let's look at some long division. Probably been a while since you've done long division, so let's kind of go through step by step. We'll try some different types of problems that I pulled from the practice of the Hawks lesson. And so when you're doing long division, you're basically doing little pieces of division over and over and over. So to begin with, what you do is we're taking this value 60. This is called the dividend, and we're dividing it by a 6. That's the divisor. But really what you're looking for, all these fancy words, is the quotient, which is the answer. We're looking for the quotient. So when they ask for the quotient, how many times does 6 divide into 60? The answer is the quotient. And if it doesn't divide in evenly, then whatever the leftover part is called our remainder. So let's start with just some that are a little smaller numbers. So let's say 6 is being divided by this 60. So like I said, you're doing little parts. You're going to start with this first digit of a 6, and you're going to divide this 6 into that 6. Well, 6 goes into 6 just one time. So you put a 1 up here. And this is a very process-oriented type of problem. You're going to always take that number, divide it into the first. Now you're going to always come back, and you're going to take whatever you wrote here times that divisor again. So 1 times 6. And you put it right here. And then you'll always subtract. So 6 divided by 6 is just 0. And you bring down a 0. You bring down whatever this number is. You bring it on down to. Well, this was kind of a lot of zeros. I wanted you to see one that had zeros falling into it, but that means that you're trying to start all over, and you're looking at this value here and see how many times 6 will go into this. Well, 6 doesn't go into 0. It goes in there 0 times, and so we would put a 0 here. And you work until you have lined up this last digit within here, the dividend. Whatever you put above that last digit, now you're done. Now, this is an example where there was no remainder. So our quotient, when you're typing this in on the homework, they're going to say, hey, what's the quotient? Well, the quotient is 10. And the remainder, well, there is not a remainder because it went in evenly. So I'd have 0 for a remainder on that one. Okay, let's try again with a kind of smaller number. Again, trying to work through that process every time. So 3 is dividing into 4. So how many times does 3 fit into a 4? Well, just once. And now you take that 1 times your 3 and you put it down here. And then you're always going to subtract. 4 minus 3 is a 1. And if you get a number here that's bigger than what this number out here is, then you didn't pick the highest number here. Now I'm picking small ones, so it's not a big deal yet, but we're going to get to that point where it is. All right, so I brought down the 1. Now you're going to bring down the next number. So the next number is a 2, and we start all over. And we look at how many times does 3 go into 12? And it goes in there 4 times. 4 times 3 is 12. And we always subtract. So once again, we're going to be in luck. We have 0 left over here. Now notice that I wrote my 4 above my 2. That means I'm done. I've done as much division as I'm going to do. And this down here is my remainder. So again, 14 is going to be considered the quotient. It is the answer. So I'm going to start using a Q for quotient and an R for remainder. And the remainder would be 0 on it. Now, we're not always going to get this lucky. Let's try some where the remainder doesn't end up 0. Now, right here, I know that 3 isn't going to go to 23 just because I know my multiples of 3. But let's look at how that process would look when you're doing long division. We'd normally look at this first digit and we say 3 goes into 2 how many times? Well, that's kind of problematic because 2 is actually smaller than 3. So it's not going to go in there at all. So I could put a 0 here, but we usually don't mess with putting a 0 for the first digit. We would just move on to the second. And so now instead of just looking at the 2, I have to look at the 2 digits. I have to look at the number 23. Now 3 will go into 23. Now, I'm not sure how well you know your times tables. You do need to know those. But if you don't go grabbing that calculator because you're not going to have access to that on the test. What you would want to do is print out the formula sheet from Canvas modules, and there is a multiplication table on the back of it that can kind of help you. So 3 times 7 is 21, but 3 times 8 is 24. So 8 would be too big, but 3 could go into this 23 7 times. Notice where I'm putting the 7 because I had to use both digits. My 7's going to go above the 3 in this case. And then I take my 7 times my 3 and I write my answer here. And then I'm going to subtract. And I get a 2. I don't have any more numbers to pull down. There's nothing left to pull down. And I've written this value above the last digit inside the division bar. So what I have here is my remainder. And this should always be smaller than what your divisor was because otherwise it would have gone in there more times. Okay, so my quotient is going to be the 7 and my remainder is a 2. All right, let's try a little bit bigger numbers, but the same situation is going to happen to me here. Now I have to look at a 75 and decide how many times a 75 will go into a 43. Well, 75 is bigger than 43, so it doesn't go into 43, which means I got to move on over to the next one. So now I have to figure out how many times does 75 go into 434. I have no idea. All right, that's okay. What we do is we kind of estimate it. What I tend to do here is I'll round this 75 up to an 80. And I'm kind of just doing this in my head. I'm going to round that up to an 80. And then instead of looking at the 80 into 434, I kind of look at this value. And I think think of the 8 and ignore the 0 from 80. Think of 8 would go into 43 about 5 times. So I'm going to estimate here then that the 75 is going to go into this 434 5 times. Notice where I put my 5. I'm using the entire 434, so I've got to put it above that 4. Now, 5 times 75. All right, now you're kind of doing multiplication, but you're sort of doing this. I'm going to show a little bit up here. I'm going to sort of do this multiplication like in my head. If I were to do this right here, 75 times 5, because that's the level I'm at, that's the stage I need to take my 5 times my 75 and write it here. Well, 5 times 75, what I'm really doing is I'm going to take the 5 times the 5. I'm going to write that answer. I'm going to carry it up to here and then multiply the 5 times 7. Well, so let's go ahead and do it. So 5 times 5 is 25. I'd carry that 2 up there. And then I do 5 times 7 is 35. Plus 2 more is 37. Okay, when I'm doing that over here, I'm going to do 5 times 5 and say, all right, that's 25. So I put my 5 here, carry that 2 over to there. And then I do 5 times 7 is 35 plus 2 more is 37. And so I'm trying to save myself from a whole bunch of side work of doing this over here. All right, now I'm ready to subtract. 14, I got to borrow here. It's going to become a 2. So it's a 14 minus 5. That's 9. All right, so now I have a 2 minus 7. That's not enough, so I'm going to borrow from the 4. So it's going to be a 12 minus 7. And then it's a 3 minus 3, which is left over. Okay, so what I don't have another value to bring down. So what I'm looking at right here is my remainder. So the quotient is the 5. The quotient is always what you have up top. And the remainder is what's left when you don't have any more numbers to pull down. Okay, let's try one more like this. A few more digits on this so you're working it through an extra time probably. Let's look at 48. This is 2 digits, so I look at 2 digits here. 48 goes into 85. Well, 48 is practically 50, so I don't think it's going to go in there twice. So I'm just going to say it goes in there once. 1 times 48 is 48. Subtract. Borrow from the 8, so I've got a 15 minus 8 is 7, and 7 minus 4 is 3. Now, if you ever get to a point where this value here is bigger than your divisor was, what that means is you did not pick a big enough number here. And so what we have to do is we would erase and we would bump that up 1. And then we would take that value times this. So if, instance, if this was 67 and it was bigger than the 48, then I would change this to a 2 and I would take 2 times the 48 and I'd be writing it here and then subtracting. All right, I got lucky here. It didn't happen. But 48 doesn't go into 37. That's why I'm bringing down the next number. You'll bring down one more number. So now we're trying to decide how many times does 48 go into 372. I don't really know. So I'm back to that whole estimating game. I would bump this up, and in my head, I'd think of it as a 50. And I would just be looking at this 5, try to ignore the last digits here. If this was a 5, it'd go into 37. How many times? Well, it'd go in 35 7 times. So I'm going to estimate 7. I'm going to go with that. Let's say it's a 7. So now, doing my long multiplication here, just kind of in my head, 7 times 8 is 56. And 7 times 4 is 28. Plus 5 more is 33. And now you're ready to subtract. All right, going to borrow from my 7. I have 12 minus 6. 6 minus 3, and 3 minus 3. Okay, I estimated good because this is smaller than that divisor. That's what I want. All right, and now I have to do it one more time because I still have another 2 to drag down. Now this is going to be my last number to pull down, and I'm going to do it all over again. I'm going to think of this. Now, this time, I'm going to get rid of this 5 here so that this doesn't mess me up later. But I'm thinking of this as a 50. So I'm thinking of the 5 going into a 36-ish. I'm going to say 7 times again. So I'm going to put a 7 here. And I really already know what 7 times 48 is because I did it earlier. But I'll go through the process. 7 times 8 is 56. Put that 5 back up there. 7 times 4 is 28. Plus 3 more is 23. And I'm ready. I'm sorry, 33. And now I'm ready to subtract. I'm going to borrow from my 6. It's going to now be a 5. And so I have 12 minus 6 is 6. 5 minus 3 is 2. 3 minus 3 is 0. So this right here is what's left over, and that's going to be my remainder. So my quotient is what I have up on top here, the 177. So 48 will go into that value 177 times with a remainder or a leftover of 26. Now, one thing we do have to pay attention to is when we're using 0 in division. Now, you can take 0 and divide it into 5 parts, and you're just going to have 0 parts. It's going to end up just equaling a 0. So anytime you see a 0 divided by something, sometimes you'll see it even as a fraction kind of division, 0 divided by 5. That just equals 0. But that is totally different than if you have a 5 dividing 0. You are not allowed, and again, as a fraction, it would look like this if you see your division like this. And you can't divide by 0. That's a mathematical property that is, it's considered undefined to divide by a 0. And so this would not be possible. And we would just write, we'd say that this quotient is undefined. And so you would just select this option right here or type undefined in as your answer. Okay, I have a couple more that are not just straightforward division, but they're more like some sort of a scenario given to you that you then have to use division to solve that scenario. Here's one I found in the practice part. It says, Kyle wishes to pay off his car loan of $7,470. He wants to pay it off in 30 months. What should he pay monthly? Well, I've got to take that total of that car loan and divide it into 30 monthly payments. So I'm going to take this 7470 and I'm going to divide it into 30 payments. And now you're just back to a normal division problem. Do you want to give this one a shot on your own? Why don't you try this by yourself? Go ahead and pause the video, try to do that division on your own, and then you can come back and see if you were right. All right, so I would take 30, goes into 74 twice. 2 times 0 is 0. 2 times 3 is 6. And I'm going to subtract. And then I have a 4 and a 1. So I got 14. I bring down my next number. So now I bring down the 7. So now I'm going to start all over. And 30 goes into 147. So it's kind of like really just thinking about the 3 would go into the 14 how many times? Well, this is really only going to go in there probably 4 times because that would go into 12. That would turn into 12. I'm going to try a 4. So 4 times 0 is 0. 4 times 3 is 12. And now I subtract. Okay, yep, 27 is less than 30, so that was a good choice. All right, I have one more number to bring down. Bring down the 0. 3 goes into 207, I'm sorry, 30 goes into 270 how many times? Well, let's just look at the 3 into the 27 to get an estimate. Well, 3 goes into 27 9 times. Now, where you're placing your numbers up top here is very, very important because that's going to tell you kind of when you're done with all your division. So I'm going to take 9, take it times 0 is 0. 9 times 3 is 27. And looky there, I end up with a remainder of 0. So what should he pay monthly? Well, that's what your quotient is right there. He needs to pay $249 monthly. All right, and I guess that's assuming there's no interest on that loan, because then he'd have to be paying more, but I think we're just going with that. All right, let's try one more like this. Here we have 16 people that are pooling their money together to buy lottery tickets. Okay, now one of their tickets wins. Yay. All right, so they win $481,600. Now, if they divide evenly among all the participants, how much money does each person get? Well, there were 16 people in on this, right? And so this money right here is going to get divided 16 ways. So let's set up our division problem. I'm going to have to write little on this one, I think. Okay, so 16 is a 2-digit number, so I'm going to put it in, use 2 digits over here, and say 16 goes into 48 how many times? All right, and we can kind of make an estimate. I'm going to go with 3 times. 3 times 6 is 18. 3 times 3 plus, or I'm sorry, 3 times the 1 is 3, plus 1 is a 4. Well, that actually worked perfectly. So I'm going to subtract, and that's a 0. All right, this is a good one for us to do because this is a special situation. I'm going to bring down my next number, which is a 1. And this is important. I have to take 16 and try to divide it into 1, but it doesn't go into 1. So I put a 0. 16 doesn't go into 1. I have to put that 0 there. That's important as a placeholder in this. And then I'm going to, okay, well, 0 times 16 is just 0. So that's not going to get me anywhere. So now I'm just going to bring down one more number. Okay, does 16 go into 16? Yes, it goes in there 1 time. 1 times 16 is 16. Subtract, I get 0. Bring down a 0. Okay, again, I don't quit. I still have to keep going because these people are not getting $301. Look how much money they want. They're going to get way more than $301. I have to keep with this process until I run out of digits to pull down. So I'm pulling down this first 0 here, and 16 does not go into 0, so I put a 0 there. If you want to put a 0 and do your subtraction, that's fine. And then I'm going to bring down another 0. And this is my last one here. 16 still doesn't go in there. But those zeros are important because now we're talking $30,000 is what everybody's going to get. And so it's important to keep track of those zeros as you're doing this. Everybody is going to get $30,100. Okay, hope these examples help a little bit. Good luck.